We're working on our combinations and permutations. And so the first part, since we're using the calculator, you're not required to write anything out. Just practice putting it in the calculator. However, there are formulas for each of these that you should be familiar with. Now, we're doing 4 permutations. Remember, permutation is when the order matters. So when we go to put this in, we are going to type in our 4, use your probability key, and then we want to select NPR. So option 1, or just hit enter, and we're taking 4, but we're picking 0. Well, there's only one way to do that. We take 0. So anytime you have a group of people or a group of items and you are not selecting any, there is only one way to do that. Now, the other ones aren't going to turn into that. Let's jump down number 3. It's a combination. We are doing 10 probability. Make sure you select your combination option, and 6. So remember, this is your N and this is your R. And that gives us 210. So nothing much to write there other than practicing putting it in the calculator. Now, so these are all permutations and combinations. Let's jump to number 7. It says, in how many ways can a teacher arrange 6 students in a row? So how many ways can a teacher arrange 6 students in a row of seats? Does the order matter? We're putting people in a row. Isn't there a first seat through a last seat? So does the order matter? It does. Think about a row. There is a first seat and a last seat. So I might have a reason to put a student in the first seat. They can't see, they're a distraction. I might have a reason to put a student in the back seat. They, are my tallest kid in the class so they can see over everyone's head. But the order does matter because it's saying how many different ways can a teacher arrange 6 students in a row of seats. So one way to do this is a permutation. Now, you have 6 students and you are organizing all 6 students. So this would be 6P6, which we didn't see before. We have 6 people, we're picking all 6, but we're arranging them. So I can do it this way, and I'm going to put in 6 permutation 6. So notice that I want you to write that down, and then my answer is 720. Now, if your answer doesn't fit in the blank, you can always write it and circle it. So 720 different arrangements. Now, before I move on, I just want to show you something. If you think about these 6 rows, 1, 2, 3, 4, 5, 6. There are 6 seats here. If I have 6 people that I'm putting in a row, the first seat has 6 options, right? I put someone in the first seat. How many kids are left to go into the next seat? I had 6 kids. I sat one in the first row. I had 6 options. I picked 1 kid. Now I have 5 kids. I put a kid in that seat. How many kids can I pick from to put here? 4. I put a kid in a seat. How many are left in my group? 3. I put another one, 2, and no matter what, I have 1 option for this last one. This is using that fundamental counting principle where I multiply all possible outcomes together. And if you take 6 times 5, 4, 3, 2, 1 in your calculator, you will get 720. So this is actually the same as that 6 factorial. So if I'm doing a permutation with the whole group, I will get the same thing as if I just did 6 factorial or I worked it out on my own. Okay, jump to number 9. There are 8 1-liter cans containing different fruit juice. How many different types of fruit juice can be obtained by mixing 3 containers together? Does the order matter? Does it say anything like it'll get messed up if you don't? Okay. So how many do I have? 8. That's my N. And how many am I picking? 3. So if the order doesn't matter, permutation or combination? Which one? Combination, the C, because the order doesn't matter. You know how people put perms in their hair? The order of the chemical of a perm matters. So permutation order matters. Combination is just grouping. So we would do 8C3. So 8 probability combination, and we're picking 3 of them, and we should get 56 ways we can make that drink. Do you agree? So 56 ways to make that drink. Okay, let's look at the back. Let me see what we have here. Let's jump down to number 17. A deck of cards marked A through Z is shuffled and 3 cards are dealt. Now this one's different because it says what is the probability. Okay, so this one's a little bit different. It's a lot harder, actually. So you have 26 cards A through Z, right? And you're going to pick 3 cards. So how many things could happen overall? Well, does it matter the order you pick the cards in? Does it say anything about picking 3 cards and laying them in a row? Or okay, so it's going to be 26 combination 3. So find out what 26 combination 3 is. 26 combination, oh no, 3. 2,600. Does anybody agree with that? Okay, so that's how many ways we can pick 3 cards. Now, it says what is the probability? Now, we did a little bit with probability, but to remind you of it, probability is a number between 0 and 1. 0 means it's never going to happen, and 1 means 100% going to happen. So I obviously need a decimal, right? I need something in between there. What's the probability the cards are A, B, and C in any order? Well, how many ways can I get an A, a B, and a C? 9. Why 9?
3. I think once because there's only one A and one B and one C.
So out of these 2,600 combinations, there's only one way we're getting an A, a B, and a C.